Is my screen visible to all of you? Hello?
Yeah, it is visible.
Okay. So, yeah, let's start, Mr.
Okay, cool. So so first let me just introduce this particular repository to everyone. So this is like the beginner coding track. Basically, it's meant like it's very beginner friendly questions are there in this particular repository. So anyone who just wants to get started with programming could directly solve questions which are included in this repository. So now let's come back. Like let's come to the main thing, that is steps how to contribute. Basically, steps to contribute. First of all, well, it's not like it is good to just start this repository so that any update, like if there is any update in this particular repository, you will be notified about it. So just start this repository, then fork this repository. There is an option to fork the repository on the top of the like on the top of the screen, the top right corner. Okay, so just fork it, and then you can clone the repository by opening the git command line and then just copy pasting this particular line of code which has been shared here. Just change your name with the name, like with your username of GitHub, like your GitHub ID. Then just press enter. Some files would be, pasted on that particular area. Then open command line and then just get into like cd, that is change your directory to that particular name, that is beginner coding track. This is the name of the repository basically. Then you need to add reference, that is like remote, to the original repository. So I'll explain that later why that's needed. So just to fetch the, like basically pull the different changes which might be made if before you make a pull request. So just to keep it, like to keep your forked repo up to date with the one, like with the main repository. So just add this particular, like copy paste this particular line in the like git command line. Then you just need to check that we have that particular remote base setup. You just need to type in this particular line again. You can copy paste it. We have made it very simple for all of you all, just to follow these steps. So just copy paste this particular line. Then you need to pull upstream, so that there might be some changes made, so that those changes would be pulled into your forked repo. Just do that, and then you can make your own branch. Because why a new branch would be basically better, as because it would basically give you, like you could compare the changes which have been made and like which were there in the main repo and which is there in your particular branch, like the main branch and your branch. So it's better to have your branch, and then we can merge it with the main branch later on when there are no conflicts there. So just create your own branch, and then you could basically start adding your code. But before adding your, like appending your code to the text, like to the particular questions text file, you need to follow this particular format, which says that you first need to write the line contribution by, and then just change those tags by with your actual name, and then write the time complexity of your particular code and the space complexity, which would be obviously taught right now in this particular session. So just do that, and then like write this code line and then add your code, and the code should be well commented. So those are the points which I have just jot down in the keep the following points in mind. That is, just do not add, like in your particular code there might be some, let's take into consideration the Fibonacci series, right? So there is a question for Fibonacci series, printing the Fibonacci series. So you don't need to write, like to take the input from the user, you don't need to mention the line like enter the number and then C, like let's say if you're using C++, C, like C out, enter the number, and then C in N. You don't need to do that. You can directly just write C in N, because like it's not needed. Then before printing the Fibonacci series, some people might do like the Fibonacci series is, or like there are pattern questions, so the pattern printing question. So you might write that the pattern is, like pattern is as follows or whatever. Do not do that. That's just unnecessary. Like it's not needed for showing like your, for basically you for practicing. It's not needed. So you can skip that part, and then So that is one thing you need to keep in mind. The other one is your code should be well commented. That is, let's take into consideration the pattern printing code. So like if you are using spaces somewhere in between and you have used, like inside a loop, you have used another loop for spaces. So you need to mention that this loop is for spaces and the first loop is for the rows. So you need to mention that so that anyone who is very new to the program, like to programming or to basically this concept of pattern printing, can directly understand from your code itself. Like no one needs to explain it to them, basically in that sense. So just make like it should be well commented. Then strictly follow the pattern which is given above, so that it is seen that you have made this contribution. Like the code which you have added is yours, is what I mean to say by that. And then also do not remove or alter the text file which you might have like in which you are making the changes, because that would just make everything a lot like fuzzy. Okay, because when we merge the pull request, we need to compare the changes first of all. So like it would be very tough for us to compare the changes, right? So do not make any unnecessary changes and just append your code in the format which has been given. Right. And then to track your changes and upload it, like after you have made all the changes, you want to push your changes on the like GitHub repo, right? So for that, you just need to track your changes. That is by using this particular command line this particular command in the git command line. Just add git add and then dot, press enter. Then you need to commit your changes. So like type a relevant message. Like you might type like you might type the name of the question itself, or you can type like your name, like contribution by, and whatever your name is. So you can type that, and then there would be just this particular line that gets pushed to origin, and then your branch name. Just follow these steps, and then come back to GitHub, like the github.com, and then you can see in that your forked repo, you could see this particular thing that will say that compare and create a pull request, something like that, something of that sort. Just press on that, and then if there are no conflicts in the sense like you might have made the changes, like you might have created a pull request after there was a change made in the main on the main branch, right? So like there might be conflicts there, so just resolve those conflicts if there are any conflicts there, and then just you can directly create a pull request. That's about it. And then we'll just sit back and we'll review it, and then if it's good to go, we could directly add it in the repo, and you would be known as a contributor to the particular repo. That's it. And then if you have any queries, you could obviously ping us directly in the pull request you might have created, or in the discussions channel on GitHub itself, just by tagging me or Satyam. And then we would reply promptly there. Or otherwise, you could directly like use our email IDs and just email us any queries which you might have. That's about it. Yeah.
Or maybe ask on the Spooky Blenders group on WhatsApp.
Yeah, that would be also.
Yeah.
I hope you all have registered, and don't worry, follow these steps. The steps are very explicitly given in the README, and don't worry, you will get it when you actually do it. It is a bit overwhelming if you are new, but when you actually do it for the first time, you'll get a very pretty clear idea about it. So if URL to the repo, okay, we'll post the URL in the chat box also, and you guys already have the repo on the Spooky Blenders group, but no problem, I'll post it here. Anything else? Yeah, thanks, Nishta. Okay, any doubts regarding the repository or how to contribute or anything which was unclear to you?
Also, like there is also a session which Akshay and Aditya took on Git and GitHub, which is there on our YouTube channel. So you can even check that out if you're having any queries or troubles while you're, forking, or you're just making your branch or whatever. So yeah.
Yeah, everyone watch that session before you start contributing. That would be like a session which is like a prerequisite. So watch that session. Akshay has taught really well in that.
Yeah.
Okay, then I'll just say let's start with the topic today, time complexity. Satyam, take over.
Yeah. Yeah, cool. So let me first present my, not presenting my screen. I will show you my paper where I will be solving and explaining everything. One second.
Efforts taken by Satyam must be appreciated. He is now going to connect his phone and show you guys how he's going to solve the questions in a notebook. So yes, yeah. So you can see that he has become a full-on YouTuber for this. So yeah, let's appreciate Satyam for this.
Yeah, 1 second. Let me match it. Great. I think it's visible to all of you, my screen.
Yeah, it's
Yeah.
visible.
Okay. So I'm considering that no one is knowing about, not much about time complexity, and everyone are a beginner to this topic. Okay. So if I talk about time complexity, basically we talk about how much time. Basically, we think that how much time our program will take, or how much time my code will take to run completely, right? So let's take a scenario that we have two people. Let me choose two names from the participants present here. Let's take okay, Shreya and one more person. Let's take one more, Deep. Okay, Deep and Shreya. Okay, so let's take a scenario. Is my screen, I think whatever I'm writing, can you see clearly?
Yes, Satyam. Yep. Go ahead.
Okay. So let's suppose we have a scenario that we have Deep and Shreya. And suppose they are given a common algorithm. Let's suppose they are given a sorting algorithm. And they were told that you both have to write a program on sorting and show it to me. So you both have written a program for sorting and you just showed me. And what you will do, you will run it. So when Deep ran his program of sorting, he took, suppose, 20 seconds. Okay. And when Shreya ran her program, she took almost, let's take 5 seconds. Now, can you guess who is the winner in this scenario? That whose program will run faster and who is having better time complexity? If you think, definitely Shreya will win in this case, right? But Deep said, "Hey, 1 second. If Shreya, like how Shreya is a winner? I am running my program on my phone, and Shreya is running her program on her MacBook Pro. Okay, so definitely, since she is having a better hardware, her program will run faster, right? That makes sense. So, what will happen? What I will do? I will run both their programs on MacBook Pro. Let's suppose that. Okay. Now, when I ran both their programs on MacBook Pro, what will happen? Now, the program will take 1 second. And since Shreya was already running her program in MacBook Pro, so her program will also take 5 seconds. But since in this case, the program is taking lesser time than Shreya, so definitely Deep will say, now I'm a winner. But Shreya says, hey, 1 second. Since we are running our programs for smaller data, like initially, suppose we took 1,000 data and we were running our program for 1,000 data. Now, she will say, if we run our program for large amount of data, let's suppose we run our program for 1 million data, then my program will run faster. So what they did, they ran their program for 1 million data, and when we check, we found that Shreya was right. Shreya's program was running at a faster rate. Okay, so if we see both the scenario, what we think that we cannot judge any program by seeing that whose program is taking lesser time, right? Everyone agree with me? Anyone? Hello? Yeah. Okay. So let's write one thing, that what are the ways to find a better program. Okay. So first thing is standardizing the underlying hardware. As we saw, if we change the hardware, the program time will vary, can vary. Okay. So this point matters. Second point is programming style. Programming style means which program is more optimized. Sorry, I think you didn't see my what I wrote just now. Okay. So programming style means which program is more optimized. So since Shreya's program was more optimized, that's why her program was better for large amount of data. It means that testing with large amount of data matters. Okay. Okay. So if these are the scenarios, then how can we judge which program is better or which program is having what time complexity? So how can we judge a program in terms of time? So to judge a program in terms of time, what we say, we will not check how much time a program is taking. Instead of that, we will check what is the rate of growth of time, or what is the rate of the growth of algorithm that it is taking. And time complexity is nothing but the rate of growth of time of an algorithm. Cool. This much clear to all of you? Yeah? Okay. Yes. Cool. Next. Okay. So now let's take an example, mathematical example, so that we can explain in a better way to all of you. Let's take a mathematical way, that what is meant by rate of growth of time. Let's take a graph. So we are considering a login graph, which seems like this. And so this is login. And let's take another graph. Suppose y equals to 20, like this. Y equals to 20. Okay. So if this is a time graph, basically this is time, this is data, and this is time. Like if we are moving forward, it means that we are taking more and more data. If we are here, we are taking small amount of data. If we are here, we are taking large amount of data. Okay, or big data, we can say. Here value of data is 10. Here value of data is maybe 10,000. Okay. Now, if you see both the functions, we have one function which is y equals to 20 and another function login. By seeing this graph, what you will, how can you say which function is growing faster? Is it y equals to 20 or is it login? Can anyone tell me? Anyone in the chat box, or maybe you can answer. Which one will grow faster at a faster rate? Like we have y equals to 20 and we have log n. So which one will grow faster or which one will take more time? Which function will take more time? We are talking about rate, not just of a specific time. We are talking about the rate of growth of time. If you see, okay, if no one is answering right now, I will explain this part and I will ask you another question after that, okay? So if you see here, you can definitely say that y equals to 20 will grow at a faster rate than log n. Y equals to 20 will grow faster than log n. But this is not true, because if we expand it more, and again, if we expand this y equals to 20, what will happen at one point of time or after one point of time, the graph of log n will be ahead of that y equals to 20, because y equals to 20 is constant. It means that for any amount, for any kind of data, it will take 20 seconds. But for this log n graph, if a program is having a time complexity of log n, it means after a specific amount of data, or if suppose this point is 10,000, so if our data is larger than 10,000, after that, always log n will be growing faster, as you can see here, because y equals to 20 is a constant, so it will not go beyond 20. But log n after some point of time, it will go beyond 20, right? Is it clear to all of you? Anyone?
Okay, so listen everyone, the whole point of conducting the session on a meet is that so you guys can actually unmute and ask your doubts and interact with the speaker. Else it would have been just like a YouTube live. So make good use of this opportunity and interact with him, so that he
And
also.
if anyone is not understanding anything, they can ask me. I will answer them. Yeah.
Cool. Okay, at least reply to this now.
Okay. Omkar replied. Okay. Cool. So I think this thing is clear to all of you. I'm assuming that. Okay. Let's take another example. Let's take another graph. Suppose this is a graph. Let's take one function, suppose log n. y upon 50. Okay. So what do you think? There are two
Satya,
functions. Yeah.
just shift your notebook a little up.
Okay. Yeah. Okay. I just forget
Yeah.
to shift my notebook. Okay. I think all of you can see my screen. Yeah.
Yes,
Yeah,
yes.
it's good.
Okay. So let's suppose we have two functions. One is log n and another one is y upon 50, x equals to y upon 50 and x equals to log n or log y, what you can say, whatever you can say. Okay, y equals to log x. Okay, sorry. And yeah, y equals to x upon 50. Okay. So we have two graphs, y equals to log x and y equals to x upon 50. So what do you think? Which graph will grow faster? Anyone? If it is not clear, I can write here y equals to x upon 50 and y equals to log x.
Log
This
X,
one and this one. Log x? Sure.
I think.
Okay. Anyone else? What's their opinion? Okay.
Yeah,
So,
me too, log x, I guess.
okay. Many of you are thinking that it will be log x. Okay. But if I tell you, if we extend this graph, suppose if I extend this graph ahead and we extend this graph also, a time will come when this graph will cross this graph. After this, it will never be, sorry, I think it, okay, sorry for that. Okay. So after this, it will not, that x equals to x upon 50 will not be below the y equals to log x. Because if we, you can like think of it, that if we move ahead and take a large and very large amount of data or very large data, it will be, log x will always be below x upon 50. All of you agree with me?
Yes.
Yes.
So basically, the one which is growing faster will be ahead of the other one for a large big data. Big data means the value of data is big, not the number of data is big. Okay. Are you getting this point?
Yes.
Okay. So this example is clear to all of you that it doesn't mean that since if you are seeing this for this like what I say, this amount of data, like for this amount of data, if you are seeing that the above graph is like the graph log x is above x upon 50, it doesn't mean that for after that we will having the same graph ahead of the other graph. It might happen that the other graph will cross the previous one, the one which was ahead of it. Okay. So every time we will see that if we take a big data, very big data, which graph is ahead in a graph, and that graph will take or will grow faster. Means the rate of growth of time will be faster. Now I have another question to all of you. If there are two functions, 1 and 2, if one is growing at a faster rate than the function 2, then which one is have a good function? Or suppose one is there are two programs, 1 and 2. One is having time complexity of something which is having time rate of growth or which is growing at a faster rate than the other program. So which program is better? Is it first program or your second program? Everyone understood my question? What is my question? If there are two programs, 1
It
and
has
2.
to be the first program because it might finish the work faster.
Okay. So I think
Yeah,
I'll have
the
to,
first one.
but this is not the case. Why? Because the rate of growth of time means, if suppose you have a program and it is growing faster, it means the rate of growth of time is faster. And since the rate of growth of time is faster, it means your program is taking more time. Are you getting that? If we are putting a large amount of data, your program is taking very much large amount of time because it is growing very faster at a very faster rate than the other one's program. So if the program is having a faster rate of growth, it means it is a kind of bad program. You will have to optimize it. You will try to reduce the rate of growth, because if you will try to reduce the rate of growth, in that scenario your program will run faster. Got it? Any confusion? If you have, then tell me. Okay, clear. Okay. So one thing is clear, always think in terms of large values, because we might confuse when we take small data or small value, and we might be wrong that this program is faster or this time complexity is faster. So always think in terms of large values. Okay. Okay, I also have one thing that I want to tell you. Suppose we have a data x upon 100 versus log x. As you have seen here, log x was growing at a slower rate than x by 100. Either we take x upon 50 or x upon 100. It doesn't make sense. Of course, x upon 100 will grow faster, since for large amount of data or for big data, x upon 100 will be ahead in graph. True? Okay. Now, what will happen if we multiply this x upon 100 with 1000? And here we have log x. Will it differentiate something, or will it make this function faster, or will it be the better time complexity if we multiply it with 1000? Anyone? If you have any doubt, then ask me, or I will move ahead. Okay, fine. Okay, so if we are multiplying it with 1000, like if we are multiplying this x upon 100 with 1000, it means
Satyam,
yeah.
Someone just asked to repeat the point which you just mentioned before.
Okay, cool. So I just said that if we compare this x upon 100 with log x, then in that case, x upon 100 will grow faster. True? But what will happen if we multiply this x upon 100 with 1000 and compare it with log x? Will the comparison be different or the same as this comparison? It's my question to all of you. Will it be different or same? Anyone? Different. Okay. Anyone else? Okay. Now, all of you are kind of right, but I will tell you one thing, that if we are multiplying a function with a constant, it means that we are running a program having the function x, having the time complexity of x upon 100 on a faster computer. Are you getting it? Like in the previous scenario, if you remember, we ran our program on a MacBook Pro and it was faster. It means that basically we are multiplying our program's time complexity with a constant value, which is making our program faster. Cool. I think this point is clear to all of you that multiplying with a constant doesn't make any change in the comparison with another function. Okay. Cool. Okay. The rate, basically, if we multiply with a constant, the rate of growth of time will not be affected. Okay. 1 second. Now, I think this is the core knowledge and that I wanted to tell you, all of you. Now, I will start with some concept which everyone should know. That is nothing but asymptotic notation. Okay. There other than that, we have some more notations, but right now we will study asymptotic notation. And in asymptotic notation, generally we study about 3 types of notations. Okay. So first one is big O notation. I will say notation here, and I will just write it like this. Okay. So this is having a symbol of this O, order of f of n, like this. Second one is omega notation. This is having symbol of like this omega and like this. Okay. And the last one is theta notation. And this is having sign of this. Okay. So these are 3 important notations which we should know. And the first one we will study about is big O notation. So what is big O notation? If I talk in a simple way that what is big O notation? So big O notation is basically the tightest upper bound. What is tightest upper bound? Tightest upper bound is nothing but the function, the function which is growing faster but nearest to the previous function. Let's take an example. Suppose this is a graph, and we have this one graph, and this is 2-second graph. So if I want to tell you, if suppose that we have a program, and this is having a certain piece of code, this code, one piece of code is taking time of g of n, and one piece of code is taking time of f of n. So what will be the time complexity of the overall piece of code? Will it be f of n or will it be g of n? So what we will do, we will find out the maximum of f of n and g of n, and the one which is the having maximum means the one which is growing faster, whose rate of growth of time is faster. Suppose that f of n is a function is having the rate of growth of time like more than g of n. It means that the time complexity of this program will be g of n. If g of n is growing at a faster rate. If I'm talking about growing at a faster rate, it means that the program basically taking more time, or the program is basically suppose I can say, like suppose this program is growing at a faster rate, means it's taking more time when that data becomes large. When the data becomes large, it's taking more time. Okay, cool. Understood? Any confusion in here? Because I think I something messed up here. So is there any confusion here? If yes, then tell me. Okay, cool. Now next is what is meant by, one second, what is meant by order of or big O of f of n. If I say order of f of n, you please consider big O of f of n. Sometimes I used to say order of f of n. So please consider it big O of f of n. Okay, cool. So order of f of n is basically a set of function that grows at most as fast as f of n. Cool. It means that suppose there are a group of functions. Suppose we have a constant one, suppose log n, suppose n, suppose n square. And if we want to say that which is a function under which all these elements will come. All these elements will come. So what we will say, if we consider order of or big O of n square, it will consist of all the elements which are growing at a slower rate than n square. Since one is what? One is a constant. If we can even write c or 1. Both means the same. Both are having the same meaning. Log n is basically running or basically growing slower than n square, because it will be like this and n will be like this. So definitely after some point of time, n will always be growing at a faster rate. True? That's clear? So
Yes.
if we talk about order of or big O of n square, it means that set of n square that grows at as fast as n square, which is nothing but 1 log n, root n, or maybe n upon 100, n upon 1000, or 1000 into n. So every function which is growing slower than n square will come under this set. And that is why this set is infinitely large. This set is infinitely large because between any two functions, we can have infinite number of functions. Okay, that is clear. So every function which is growing slower than n square will come under this set, and that is a part of order of or big O of fn. Oh, sorry, big O of n square. Clear? Now let's talk about a general function, general equation of it. Okay. Order of f of n. So we are considering g of n. So there exists c greater than 0 such that g of n is less than equals to c into f of n for all n greater than n naught. What is n naught? N naught is basically a specific value which is very large. Means after that, only one function will be ahead of the other function. Like here, after this point of time, n will always be ahead of log n. It means we can consider this point as n naught. Clear? This much is clear to all of you? What is mean by n naught? Anyone? I'm waiting. Anyone?
Clear.
Okay, cool. So now let me explain this part. What is this function? Basically, it is a function where there is some constant c which must be greater than 0, and every function that is g of n which is less than equals to a constant times of f of n, that will be a part of order big O of f of n. So let's consider big O of suppose n square again. So if we are considering big O of n square, so every function g of n which is less than equals to c times of n square will be a part of its set, because order of n square is basically a set of functions. So every function g of n which is less than equals to n square will be a part of this set. Cool. So what are the functions which are less than n square? C times of n square. So it will be like 1, that is constant, log n, root n, then any number or any function which is growing slower than c times of n square, or even equals to n square. N square will also come under this set. That will all comes under this set, which is nothing but big O of n square. Now let's talk in terms of a function like a graph. Like suppose this is a graph. We have this function, and this is another function. This is f1. This is this is f of n, and this is suppose okay. So this is f of n, c types of f of n, and this is g of n. Okay. So it means that if we take this point as n naught, so after this point, every time g of n will be either less than or equals to c times of f of n. That is meant by this general equation. That is clear? Okay. If it's clear, I can move ahead. Is it clear to all of you?
Yes.
Okay, cool. So till this point, is there anyone who is having any doubt or any question? Just ask me if you have. No one? So I am considering everything is clear to all of you. You have no any doubts till this point. Okay. Okay, so let's move ahead. So now we will talk about some general functions about which you will come to know when you will go through the different program, and you will be asked to find time complexity. So what are the normal or common functions about which you should know? So the first function is C. So big O of C is basically big O of constant. We can also write this as big O of 1. Another is a logarithm, which is big O of log n. There can be any base of it. Then we have square root, big O of root n. Then we have n square. I am writing it in the form that increasing rate of growth of time. its growth is extremely slow. If its growth is in more than order big of 1, so I am writing it as the rate of growth of time is increasing as I go downward. Okay. So after that, which we should know, which is n cube 2 to the power n, either 1.5 to the power n, that is exponential. But yeah, the base should always be greater than 1. That one thing that should be clear to all of you. Then after that, if we increase more rate of growth of time, we'll have n factorial, then n to the power n. So these all are common functions which you might see in your program, basically in your code, finding time complexity. So these are common functions. Clear? Then I want to ask you one question. Is there any function whose rate of growth is slower than a constant? Is there any function? Anyone? As we have seen that a constant grows very slow, like other than root n square n cube, a constant grows extremely slow. But is there any other function which grows slower than a constant? Anyone?
1 upon x.
1 upon x. Okay. So one thing, let me clear it you that if you talk about 1 upon x, basically we are talking about 1 upon something, 1 upon 2 or 1 upon 3, like, right? But you won't get anything that will be 1 upon 1 lakh. That means that your program is like inverse, taking very much little time, and that will come under a constant. In terms of time complexity, there is nothing slower than a constant or lower than a constant. That you should remember. You are right that 1 upon x will be basically will have a value lower than 1. But in this case also, if you consider 1 upon x, you will write order of 1, because in time complexity we don't consider anything slower than a constant. Clear?
Yes.
Okay, cool. So one thing is clear: slower growth is same as or means a faster algorithm. So our algorithm whose rate of growth of time is slower, that will be a faster algorithm. That is clear? Okay. I'm assuming everything is clear to you till now. Now let's move on to the next thing, that how to find time complexity of certain types of codes. Okay, let's do that. Okay, so let's take a simple example. Int, okay, I think you can't see. Yeah, int I equals to 10 and print I. Can anyone tell me what will be the time complexity of this line of code? Anyone?
It will be a constant.
Okay. Why it will be a constant? Can you little bit explain? No point.
It's
Nobody.
just printing the 10. So I don't think it's taking his time.
Okay, right. You're right. you are almost near to the right thing, but
There is
I
no
want to
variable, no input can affect this.
what did you say?
No input will affect the working of the program. It will work on
Yeah.
its own.
Okay. Okay. Cool. Okay. So yeah, you are right. It will take constant time. But why it is taking constant time? Because in this program, what we are doing, we are first declaring this variable, and in declaring any variable, the program takes a constant amount of time. Second thing is we are initializing this variable. So again, in initializing a variable, a program takes constant amount of time. And the third thing what we are doing, we are printing this I. And again, in printing any variable, a program takes constant amount of time. That's why, since it is taking some time, suppose a amount of time in declaring, B amount of time in initializing, and C amount of time in printing. So which is basically a constant. So A plus B plus C will not be anything other than constant. That's why the whole program is taking constant amount of time. Okay, clear? This is clear?
Yes.
Okay. Now let's take another code. Suppose we have for int I equals to 1, I less than equals to n, I plus plus. I think you are familiar with this C++ code. Is there anyone who is not familiar with this code, kind of code, or should I explain this part of code? Anyone? If anyone is not familiar, I will explain this. What does this mean? Or I will explain about time complexity. So I'm assuming everyone knows about this. Okay, explain in short. Okay, cool. So basically, this is a syntax of C++, and basically we are declaring I variable int. Int means data type is integer, and we are declaring it and initializing it with 1. And this is a condition. It means that this program, this print function, will run only when I is less than equals to n. And I plus plus means after every printing of this, I will be incremented by 1. So I plus plus, it's same as I plus equals to 1, or I equals to I plus 1. Clear? I think this is clear to you, all of you. What does this code means? Now let's talk about time complexity. Okay. So if I'll have to talk about time complexity, basically it means that the number of times, or the order in which this print function will run, that will be the time complexity. It means, suppose that if my program runs, and if this print function runs, suppose n number of times, so basically n times of order of 1, which is nothing but printing time taken to print this print function one time. Order of 1 means time taken to print this print function one time. And why I am multiplying this with n? Because I am printing this print function n times, because I'm using a loop which is running n times. So this program will be having time complexity of order of n, because we are doing nothing but n times of order of 1. Okay, clear? This is clear to all of you?
Yes.
Yes.
Okay, cool. So let's go little deep into a program, and let's take some little complex program. Okay. So I am taking a if-else condition. If-else condition. Suppose this is a if statement. There is some code. This is, sorry, I think you are not able to see. Okay. This is else condition. There is some code, and the code which is inside it, if we run this code, means if condition is satisfied, this code will run, and if this code will run, the time which that it will take, that will be of the order of, suppose its function will be f of n. Okay, f of n. And if condition is not satisfied, it means else condition will be satisfied, and this code will run, and the time complexity will be basically the time it will take will be g of n. Okay, so if I ask you one thing, what will be the time complexity of the overall piece of code? What do you think? What will be the time complexity of the overall piece of code? Anyone?
Sir, can you move it to a little left?
Okay. Left. Okay. Is it visible?
Yes.
Okay. Cool. So I think the question is clear to all of you, and that if condition is satisfied, this code will run, and if this code will run, it will take around time of the in the order of f of n. And if condition is not satisfied, else condition will satisfy, and this code will run, and if this code will run, it will take time of g of n. So what will be the time complexity of the overall piece of code? Will it be f of n, or g of n, or combination of something?
Sir, if it depends on or g of n.
You are not audible. Can you say again?
Sir, depends on the satisfaction, but satisfaction of the condition. It would be f of n or g of n, only one of them.
Okay. Okay. You are near to the right thing, but it's not completely true. But yeah, you are almost right. So basically, if I want to find out the overall time complexity of the complete code, so I will say the time complexity will be or maximum of, sorry, order of maximum of f of n comma g of n, or I can say order of f of n plus g of n. Why I am writing maximum of f of n comma g of n? It means that suppose f of n is growing at a faster rate, okay, and g of n is growing at a slower rate. Of course, if f of n is growing at a faster rate, g of n will be slow. Okay, so definitely in any case, if any program will run, f of n and the time complexity cannot be more than f of n, right? Because f of n always grows faster than g of n. This much is clear? Yeah? Okay, so Akanksha wrote something. If else is just one statement, cause either one of the one will be executed if it does not neither increase or decrease the complexity. Is it right? Yeah, Akanksha, you are right. But yeah, it doesn't matter whether if condition or else condition will run, but we must consider that if the running or if the probability of satisfying the condition of if statement and else statement is same, in that case your time complexity will not be affected. But yeah, if you want to find out the overall piece of code, not just a single piece of code, you will need to take both of them into consideration. Okay. Okay, cool. So basically, maximum of f of n comma g of n means the one which is growing at a faster rate will be the time complexity of this overall piece of code. This is clear. And even instead of writing in this way, we can write in this way also. Both of them have the same meaning. Okay. So if I want to prove why both of them are having same meaning, we can prove in this way. What was the general function of general equation of order of f of n? It was g of n less than equals to c times of f of n, right? So let's take first the above one, this statement or this function. What it will say? It will say f of n comma g of n max is less than equals to c times of f of n plus g of n. If this condition will satisfy, also f of n plus g of n less than equals to c times of max of f of n comma g of n. Okay, so if both this condition will satisfy, it means that both the equations are same. If you see it like this, okay, I think you are not able to see that. Okay, I think now you can see this. So if x is less than equals to y and y is less than equals to x, what does this mean? It means that x equals to y, right? In the same way, if max of f of n and g of n is less than equal to c times of f of n plus g of n, also if f of n plus g of n less than equals to c times of maximum of f of n comma g of n, if both the conditions satisfy, it means that both the equations are same. Okay, clear? Now one thing I want to tell you how this condition satisfy. If we take the first one, this one. If we take this one, how can we prove this? Instead of writing maximum of f of n and g of n, let's suppose that f of n is larger. Okay, let's suppose that. So what we can write? F of n is less than equals to c times of f of n plus g of n. And this is, I think, very much clear that definitely f of n will be less than c times of f of n plus g of n, because it is also having f of n plus g of n. So definitely f of n will be lesser than this equation. True? Is this true? Anyone?
Yeah.
Okay. Now if we take the second equation, f of n plus g of n. Instead of writing f of n plus g of n, we can write like this. Suppose f of n is larger, or so we can write like this: twice of f of n minus some sigma. This is value because this is the value I am writing because g of n is lesser than f of n. So if we write twice of f of n, it means will have to subtract with something. So 2 of f of n minus sigma less than equals to c times of f of n. Now I can use any number instead of c. If I use suppose 3 as c equals to 3, definitely 3 times of f of n will be larger than twice of f of n minus sigma, right? Because we can take any value instead of c, any constant. So if we take 3, and this equation will satisfy. That means both 1 and 2 are satisfying the equation. And since both the 2 are satisfying the equation, it means both the left side equations are same, right? Is it clear? Everyone?
Yes. Yes.
Okay. So this is all about order of f of n, big O of f of n. Now I will just take 2 or 3 examples of code, which is actually really important to know. After that, we will end the session. Okay. So let's take 2 or 3 examples. They are a little complex, so I think this is important to know. Okay, 1 second. So first, let's take code of, first let's take code of nested loop. So in nested loop, what we do, we have one loop inside another for loop. So we have I equals to 1, I less than equals to n, I plus plus. Then we have for j equals to 1, j less than equals to n, j plus plus, and inside which we have a print function, print of I plus j. Now, can anyone tell me what will be the time complexity of this whole code? Or even you can tell me how many times this print function will run, this print function. Anyone? I think you are
N square.
you can n square. Okay, cool. All of you are right. There is no problem, because why it is n square? Because of course this part will will run basically will help this print function to run n times. And since this part helps this print function to run n times, and also in this for loop is running n time, so definitely n times of order of n will be the time complexity of the overall piece of code. Clear? Yeah?
Yes.
Okay. So I think I don't have to explain much about this part. Let's move on to a more complex code. Let's take another code. Suppose we have I equals to, for I equals to 1, I square less than equals to n, I plus plus, and printing I. Now, what do you think? What will be the time complexity of this part of code? Anyone? You can reply or write in chat box. What will be the time complexity of this part of code? If you don't know, just write down no. At least I will get to know that people don't know about this part. Anyone?
Root n.
Yeah, true. Good. Good, Rishikesh. You are right. It's root n. Okay, people, why it is root n? Because the number of times this print function is running or getting is running is basically root n. Why root n? Because when I was equals to 1, this print function ran. Then when I was equals to 4, because when I becomes 2, then we check with basically I becomes 2, but 2 square is 4, and 4 is less than equals to n. So it will be like 2 square is less than equals to n. That's why print function will run. Then I becomes 3. And since 3 square is 9, if 9 is less than equals to n, again this print function will run. But when will this print function stop printing or stop running? When I square will be less than equals to n. So how many number of times this print function will run? When this condition will satisfy, and till what point of time this condition will satisfy when I is less than equals to root n. When if we transfer this square to right side, you will find out I is less than equals to root n. And since this print function is running root n times, That's why the time complexity of this overall piece of code is root n. Clear?
Yes.
Is this clear to all of you? Okay, cool. We'll just take 2 more code, and after that this session will end. Okay. So one code is for I equals to 0, I less than n, I into equals to 2. Then print I. That's it. Okay. Okay, sorry. I think I just moved my camera. Okay. Okay. Cool. So what is the time complexity of this piece of code? Can anyone tell me? Anyone?
Can you repeat the for loop you've written?
Yeah. Basically, what I am doing, I am initializing I with 0, or you can say 1. Anything is fine. So I am initializing I with 1. I less than equals to n. I multiply I into equals to 2. So basically, I am multiplying with 2 every time. Okay. And inside which I am printing this I variable. So I'm asking what will be the time complexity of this overall piece of code. Please answer, anyone. If you know, if you don't answer, just say don't know anything. Okay. So I into equals to 2 means I equals to I into 2. Basically, so after every time, means suppose
2
I
raised
equals
to n.
to 2 raised to n. Okay, so okay, anyone else? So I was saying this. It means I into equals to 2 means I equals to I into 2, and it means basically first time I will be 1, then I will be 1 into 2, which is 2. Then third time when this loop will run, I will be 2 into 2, 4, then 8. That's why, and it will move on like this, 1, 2, 4, 8, like this. I think this is clear that what is this mean? What does this mean? I into equals to 2. Okay, so anyone who can tell me about the time complexity of this code other than 2 to the power n, or this is same? Like everyone is thinking the same way. Okay, okay. So let me just explain this part. Basically, its time complexity is not 2 to the power n. Its time complexity is log of base 2n. Why this is log of base 2n, I will tell you. So I initially told you the number of times this print function will run, that will be the time complexity of the overall piece of code. Okay. So initially, as you can see here, initially I was 1, and since 1, let's suppose 1 is less than equals to n, so I was the condition satisfied. Then I became 2. Again, let's suppose 2 is less than equals to n. Then this condition satisfied. Then I became 4, and so on. I became something. Let's suppose I ran for k times. Means this print function ran for k times. So basically, what is happening? 2 to the power k less than equals to n. This question is clear to all of you? Why 2 to the power k less than equals to n? Suppose this print function ran k times. So it means 2 to the power k less than equals to n. Clear? This is clear to all of you?
Yes.
Okay. So if 2 to the power k less than equals to n, now let's take logarithm with the base 2 on both sides. So if we take logarithm with base 2 on both sides, it will be like this. less than equals to log of base 2 of n. Okay. Now, since k is in power, we can take it outside. Log of base 2 with the value 2 less than equals to log 2n.
Satyam, please adjust the paper. No?
Okay. Yeah. Is it visible?
Yes.
Yes.
Okay.
Thank you.
Yeah. So till this, any problem, any doubt in understanding the equation? Any doubt?
So just one doubt. If the I runs k time, then it will be 2k plus 1, na?
Okay. So, okay. Suppose I was 1 initially. Okay. And
Yes,
I
yes.
want to, suppose k equals to 3. Okay. So I will be 1, then 2, then 4. It means 1 into 2, then 2 into 4, 2. Right. So if I'm multiplying 1 with 2 k times, yeah, I will be getting values nearest to n. Nearest to n. I'm assuming that. Or equals to n. That's
Yes,
true,
yes,
no?
got it.
That's why, because we are multiplying with 2, not just like this. If you, as you said, 2 times of k plus 1, it means that we are printing this function like this. Let's suppose, okay, um, like this. 1, then 2, then 3, then 4, like this. Twice of k, like 2k plus 1. But we are not printing this function like this. We are printing like this: 1, then 2, then 4, then 8. So every time we are multiplying with 2. It means 2 multiplying 2 with k times, so that the number after that which will come will be equals to n. That's why we are writing 2 to the power k less than equals to n.
Actually, Satyam, he meant, I just asked him in the chat box, he meant what about 2 raised to k plus 1? So, Rishikesh, even if it is k plus 1 times, so, see, for now, Satyam is explaining it for the sake of this example. But even if your loop runs for k plus 1 times, then
Okay.
just understand is that when you are taking the log here, then it would k plus 1 would come on the left hand side of the log, and k plus 1 still would be a constant, so it wouldn't actually matter whether it is k or k plus 1. Are you getting it?
Yes, got
Okay.
it.
So basic. Okay. So k is not a constant. Okay, because the constant is something about which we know earlier. Okay, but we don't know what is the value of k. So k is not a constant. One thing should be clear. And second thing is, since 2 to the power k is less than equals to n, we can just take it outside, and k will be like that: k into log 2 of 2 less than equals to log 2 of n. Okay,
Yes, got
this
it.
is clear. Okay, now if you know logarithm, you must know that if we have the base and the value inside here is the same, then the logarithm of it is 1, equals to 1. I think all of you know about it. That if
Yes.
we are having like log of a and a, that will be equal to 1. So this part will become 1. And therefore, k will be less than equals to log of base 2n. And k is nothing but the number of times this print function ran. Okay, are you getting it?
Yes.
Okay, so since the time complexity is nothing but the number of times this print function will run, that's why the time complexity is order of k. And since k is equals to or nearest to log of base 2n, therefore we can also write it as order of log of base 2n. Now, one thing I want to tell you, here we were having I into equals to 2. But if we had I into equals to, suppose, b, then the time complexity would be log of base bn. Okay? And I don't think this will be confusing for you, because if you are multiplying with b, it will be like 2 to the b to the power k less than equal to n, like this: b to the power k less than equal to n. Clear?
Yes.
Understand this part very clearly, because see, you can also look at it the other way, that what if I divide n constantly by 2?
Yeah.
So are you getting it? If I divide n constantly by 2, then also I'll get 2 raised to k less than equal to n. And that is an important thing to understand in future, because there is a method called binary search, in which this would be really helpful. So if you have any doubt
Right.
regarding this, ask it right now.
Any doubt?
Just once repeat it.
Okay, let me repeat it from the starting. Okay, so one thing I want to ask you, b to the power k less than equals to n, is it clear to you, or should I explain this part also?
No, it is understood.
So if this is understood to you, it means you know that what will be the value of k, that will be the time complexity, because k is nothing but the number of times the print function is running, right?
Yes.
So if we can find out the value of k, it means we have find out the value, and the value or the function for time complexity, right?
Yes.
So we will apply the same thing. We will apply log with the base b, log with the base b here. So if we apply log with the base b, it will be like log of base b, b to the power k. I'm writing here. I think there will be no problem with all of you. I can separate it. Okay.
Just move it to a little left.
Okay.
Yes,
Is it
got
okay? Okay. So less than equals to n. So I think this function and this equation is clear to all of you. This equation, is it clear?
But we have to take log on left, right also, no?
Yeah, right. Sorry. Yeah, right. Also, log of base of n, b of n. Clear?
Yes.
Okay. So now only one thing we have to do. We will take k outside because it is in the power. So k will become outside, and we will be having log of base b with the value b less than equals to log of base b of n. And this part is 1, because we know that if base and value is same, the logarithmic of that is 1. So k will be less than equals to log of base b of n. Clear?
Yes, sir.
So, and since k is nothing but the time complexity, that's why log of base b of n is the time complexity of the piece of code for which we are having I into equals to b. Clear?
Yeah. So first value printed will be 2 now for this function.
No, the first value will be 1. Then it will be 1 into b. That will be b. Then it will be b square, then b cube, till b of something, b to the power something is less than equal to n.
So initially I would be 1 only, right?
Yeah, 1.
Okay.
Clear?
See, like for the for loop, the first value that we have initiated is 1. So for that it will run, and then for the next time it will check the condition, right? Then it will
Yeah.
update the value. So for 1 it
Yeah.
will always run.
So it
Okay,
depends
got
on
it.
your initialization, which value you have initialized with. If I have initialized with 1, that's why it's printing 1. If I had initialized with something, suppose 5, so at first it would print 5, then 5 into b, then 5 into b square, like this.
Yes, got
Got
it.
it?
Yes. I thought
Okay.
in first only for statement the I is increased to B.
No. At first, the initialized values will get printed. Then after, it will get multiplied with the value b that I had written, and it will be like it will print I into b. Got it? The
Yes,
initialized
got it.
value into b.
Yes.
Yeah,
Okay.
so I guess the homework for you all will be to go and learn about the binary search and
Yeah.
how they are deriving the time complexity for binary search. So do that for the next session. And I guess we will wrap it up here, Satya.
Yeah, okay. I think I have completed the concept of this big O notation and time complexity. I think if you know this much also, you can find time complexity of many programs. But yeah, if we find some time in the next session, we can take some more topics in time complexity. Yeah.
Yeah, and don't worry, because in every session that we will take, we will sort of discuss time complexity of a program. So if you have doubts even over there, we can clear that out. So I hope you all understood whatever Satya taught you. If you have any doubts, you can shoot them right now. Okay, I'll just call everyone by their names and ask them if they have a doubt. Rishikesh, do you have any doubt?
Actually, when we thought k is coming in form of log, right? So many times log gives value in decimal. So how can a program run decimal times? Like we know one time, two time, three time is
Yeah.
okay, but decimal times is like little.
Yeah, because you are running a program in mini, like your program may also take 1.5 seconds or zero point 0.5 seconds or maybe 1.55 seconds, because programs runs very fast. Getting, like you can't judge a program in integers. It will be a real number. It can be any number.
And Rishikesh, this is not about how many times your program has run. It is the time complexity. The functions
Yeah,
are
and
representing the
yeah,
time function. Yeah.
the program in the as I initially told you, you will not be thinking of how much time your program took. You will be thinking of what will be the order of like time, like what will be the time complexity, the rate of growth, how which what rate your program is growing, your program and your program time is growing if you give more and more data to it. Getting.
Yes, means it is not about count. It is actually about time, right?
Yeah, it's about time, but in terms of rate of growth. Suppose let's take a constant. Suppose we have a constant y equals to 20. It means that your program is taking 20 seconds. Okay, 20 seconds in every case. How much data you give, whatever last data you give, your program will only take 20 seconds. But there's another program which is having time complexity of suppose y or x, y equals to x. It means that if we increase the uh, data size, your program will take more and more time. So initially you will think of your program is taking lesser time, but if you increase the data size, your program will take more and more time, and eventually it will increase the value of 20 also. So in that case, what will you say? What will you say? That this the program which is having time complexity of y equals to x is not good, or is not better than the program which was having time complexity of y equals to 20. Got it? So you will
Yes.
think. So
Means time
always think.
complex. Time complexity. The lesser the program is better.
Yeah, yeah, absolutely true. So whenever you think, and just think in terms of rate of growth, that the growth and the rate of growth is, if the rate of growth is faster, the algorithm is not is little bad or not better. If the rate of growth is slower, the algorithm is faster.
Okay. Means the
Got it?
program should reach the final output in less time.
Yeah, less time.
Yes, I got it.
Okay, good. Any more questions?
Cool, then people have started leaving the meet. So yeah,
Okay.
let's just say sayonara and see you in the next session. Yeah. Cool then.
Cool.
Yeah, thank you all for
Yeah.
joining.
Thank you, everyone.